Hi Math 2 Enhanced. Let's talk a little bit about what we did in class today. So on the left side of page 21 in our packet, we graphed the equation 1/2 parentheses x minus 4 squared minus 2. So this is the vertex form of the equation, and it tells me the vertex. I can see that my vertex is the opposite of what I see in parentheses, so positive 4, negative 2. So I'm going to go to positive 4, 1, 2, 3, 4, and down 2 on my x-axis, and this is my vertex. I can graph it from the 1/2. I know that my quadratic movement is 1, 1, 2, 4. But when my a is 1/2, my y movements are only half as much as what they would have been. So I'm only going to go up a half, and when I go over 2, I'm only going to go up 2, half of what it would have been. So over 1 up 1/2, and to the left 1 up 1/2, and then over 2 up 2. I see an x-intercept. Over 2 up 2. And then I could do 3 and 4.5 if I wanted to, because it would have been 3, 9, so half that's 4.5. So let me do 3 and then up 2, 2 more and a half. And then over here, over 3, up 2 more, and then a half. So I have my parabola that's looking a little bit like this. He is wider because he has an a value of 1/2. So my y-intercept. Well, my y-intercept occurs when my x-coordinate is 0. So in this problem, y equals 1/2, 0 minus 4 squared minus 2. Now doing PEMDAS, my parentheses first, I would have a negative 4 in my parentheses. Keeping with PEMDAS, exponent second, negative 4 squared is positive 16. So now I have 1/2 times 16, which is 8 minus 2, or 6. So it looks like my y-intercept is going to occur at 0, 6. And you could put that on your graph and also use that to help you graph your parabola. Now my x-intercepts, well, x-intercepts occur when my y value is, when my y value is 0. So 0 equals 1/2 x minus 4 squared minus 2. So generally when we solve, a lot of times we use factoring, or we use quadratic formula, or we use completing the square. But all of those work depending on my problem if it's in standard form. This problem's not in standard form, it's in vertex form. And a handy dandy way to solve vertex form equations is by taking the square root of both sides. So I'm going to isolate my square term. I'm going to add 2 to both sides. I get 2 equals 1/2 times x minus 4 squared. I'm going to further continue isolating my square term by multiplying both sides by 2. This is 2 over 1. It's the reciprocal. Instead of dividing by 1/2, I'm going to multiply by the reciprocal. So I'm going to multiply both sides by 2. My 1/2 cancels, and I get 4 equals x minus 4 squared. Take the square root of both sides. I get plus minus 2 equals x minus 4. And then lastly, I'm going to add 4 to both sides, slipping it in front of my plus minus. When I add 4 to both sides, I get 4 plus or minus 2 equals x. So it looks like my x-intercepts are going to be 6 or 2. And I can actually see them on my graph. And if you're thinking, oh, I know them, I can see them, great, but could you find them algebraically? If you couldn't see them, do you know how to solve that equation? So my x-intercepts are going to be 6, 0, and 2, 0. So domain and range. Well, the domain for all parabolas is all real numbers. You can either write it with your all real numbers symbol or negative infinity to infinity. And that's because, let me grab a yellow highlighter. That's because as I look across my x-axis, any value of x can be substituted in, and I could find it somewhere on my red parabola. So for example, this value of x right here, let me get a different color. Sorry, let me go back to red. This x coordinate right here coordinates with some y coordinate up here that would be on my parabola. So every x value of x is somewhere on my parabola. However, when I look at my y-axis and I start at the bottom, I notice, so for the range, I'm going to look from the bottom to the top. Starting at the bottom, there's no graph down here. So my y values don't really start until I get to my minimum of -2. That's my vertex. So my range starts when my y values are -2, so a bracket to include it, not a parenthesis, and continues going on forever because my arrows point straight up. So this goes on forever to infinity. Now, on the last part in class, I had asked you to write this in standard form as well as writing it in factored form. So if you're having trouble with any of this, I would encourage you to go back and look at either page 13's notes or 16 and 17. And I bring that up now because on page 17, we did exactly this. We changed a vertex form of the equation into standard form by multiplying. So to change this into standard form, I would write my x minus 4 twice. So I remember to multiply it times itself. That's what it means to be x minus 4 squared. So I get y equals 1/2 x squared minus 8x plus 16. Now by PEMDAS, you have to do multiplication before you can do the subtraction of 2. So I'm going to distribute my 1/2 into my parentheses, and I'm going to get 1/2 x squared minus 4x plus 8. I still have my minus 2, so I'm going to combine those two. When I write my answer, I have 1/2, or I should have put a y there. I'll put it behind it, I guess. 1/2 x squared minus 4x plus 6 equals my y. Now my factored form, if you go back and look at page 13, you'll see that it says under factored form that it's a times, I think they use p and q. They say x minus p, x minus q, where p and q are my x-intercepts. So I'm just going to slide my numbers into the formula. So in factored form, this would be my a is 1/2, and my x-intercepts were 2 and 6. So my factors are the opposite of that. My factors are x minus 2 and x minus 6. That's so when I set my x minus 2 equal to 0, I would get x equals 2, one of my x-intercepts. And when I set my x minus 6 equal to 0, I would get my x equals 6, one of my zeros. So I hope that was helpful for the first problem. So now let's look at the second problem. That problem was in standard form. Y equals -x squared minus 8x minus 13. So I hope you, and continuing, page 13, 16, and 17 are really good pages to look at for some extra help here. So I hope when you see this, you instantly think that since it's in standard form, I know the x coordinate of my vertex and also my axis of symmetry is -b over 2a. In this problem, that is a -8 over 2 times -1, positive 8 on top, -2, so I get -4. Great. So I know the x coordinate of my vertex is -4. Now let's do substitution and find my y coordinate. I'm going to plug that -4 in for x. So I have a negative in front because that's my coefficient, -4 squared minus 8 times -4 minus 13. Well, by PEMDAS, I do my exponents first. So -4 times -4 is positive 16, but there was a negative out in front, so that would become a -16, plus 32 minus 13, and I believe that would give me a. So we'll graph -4, 1, 2, 3, 4, and then up 3. And so my a is -1. So now when I do my 1, 1, 2, 4, I'm going to move down. So 1, 1, moving down, 1, 1, moving down, 2, 4, moving down, 2, 4, moving down. And you could do your 3, 9 if you wanted to. Okay. So my y-intercept occurs when x is 0. So y equals, that goes to 0, minus 8 times 0 goes to 0. So I just get my -13, which is my c. So that would be my y-intercept. My x-intercepts are when I let y be 0. So this problem, I think it doesn't factor. I think the easiest thing to do here is just quadratic formula. My a is -1, my b is -8, my c is -13. So I get x equals negative b, which would be +8 plus or minus b squared, minus 4 times -1 times -13, all over 2 times -1. This gives me 8 plus or minus. Now be careful underneath your radical. Some kids are having trouble with this. This is a -4 times a -1, so +4 times a -13 is a -52, all over -2. So underneath my radical, I have 12. So this is the square root of 12 over -2. At this point, I'm going to stop simplifying because this doesn't ask for it in radical form. It just asks for the x-intercepts. And when I'm graphing, it makes more sense for me to check my answer in decimal form. That's what I can easily look and see on my graph. So I plug in 8 plus the square root of 12, hit equals, divide by -2. You should be getting a negative 5.73. And when you do 8 minus the square root of 12 divided by -2, I believe you're getting a -2.3 or vice versa. But work those out on your calculator. And so my x-intercepts are negative 5.730 and -2.30. I can look at my graph and see that those make sense. This is kind of close to -2. It's just to the left of it. So -2.3 makes sense. This is just before -6 on the x-axis, so -5.73 makes sense. My domain, again, is all real numbers for my x-coordinates. In other words, any value of x can be substituted into this equation, and I'm going to get a value for y. That's because my parabola continues growing outwards and down forever and ever. My range are my y values, but if on this particular one, if you start thinking about starting at the bottom of your y-axis and going to the top, there is values of y down here that are on my parabola because it's going to continue going down forever and ever and ever. So negative infinity is where my range would start, and it goes up to +3 and it stops. My y values are never greater than +3. That's because I have a maximum. My maximum y value on the function is 3. So my range is going to end at 3. On this one, I asked you to write it in vertex form. So to write this one in vertex form, remember vertex form is y equals a times x minus h squared plus k. So in this problem, my a is -1. You can write a negative or you could write -1. It doesn't really matter. Parentheses x minus the x coordinate of my vertex. So this is x minus a -4 squared. And then plus k, or in this case, +3. And yes, x minus a -4 is a positive. So I would take a moment and change that to x plus 4 in parentheses. And we're all done. I hope this was a helpful explanation of these two graphs. Thank you.